So guys, this unit is all going to be about factoring. Factoring is basically undoing the multiplication we did from our last unit. We are going to get the things back into their parts or their factors. So the first step when we factor is we want to find the greatest common factor. So guys, the greatest common factor is the product of the greatest integer and the greatest power of each variable, and we'll talk about that in just a second, that can be divided evenly into each term. Okay? So if I ask you to find the GCF, or the greatest common factor, we want to find basically the biggest thing, the greatest thing that can be divided evenly into each term. So this will be a good reminder here. What is the GCF? All right, so we're going to find our GCF here of a couple nice little problems. So for number 1 here, what is the GCF between 18 and 27? What is the greatest common factor between those two guys? So you have to think about the different factors of each term here, and we want to find the biggest one that they have in common. So y'all, what is the biggest number that will divide evenly into 18 and 27? Anyone help me out? 9. Okay? So 9 will divide evenly into both 18 and 27. All right? I want to show y'all a cool little trick on the calculator real quick for how to do that. Yikes. All right. So let's see here. So if I turn on my calculator here and I type in 18 divided by x and 27 divided by x, so I typed in both of those guys, and I go to my table. Okay, so guys, what's kind of cool about this, I'm going to zoom in just a smidge so y'all can see. What's kind of cool about this, guys, is when you do your table, your whole number pairs are the factors of those two guys right there. So we know 2 and 9 are factors of 18. 3 and 6 are also factors of 18. 3 and 9 are factors of 27. So guys, what you want to do is you want to find the number that has the highest number that has 2 whole number pairs there. So guys, the factors of, so the highest one would be 9, because look, it divides evenly into 18 2 times and evenly into 27 3 times. All right? If you keep going, you'll see there's no more whole numbers after that. So the highest one that has whole numbers with it is number 9. So that's kind of a cool little calculator trick if you have a hard time thinking of those factors in your head. Now, what I'm going to do right here, guys, is I'm going to show y'all, I'm going to do this with little upside down division. All right? So, Emiliano told us that the greatest common factor was 9. Well, guys, 18 divided by 9 is what? What's 18 divided by 9, y'all? 2. Okay? What is 27 divided by 9? 3. So how you can kind of check yourself is you look at this and you say, do 2 and 3 have anything else in common? Can those be factored at all? No. So we know we reached the greatest common factor right here with 9. So guys, in this case, my GCF is 9. Do y'all feel good about that? So if I just ask you for the greatest common factor, you just have to give me what it is. Okay? Now sometimes, guys, you might have a variable. Okay? So I'm going to go here. And so let's take a look at this. If we look at our variable factor here, I'm going to say we want to find what is the greatest common factor between x cubed y, x squared y squared, and xy cubed. I don't know why I did my y different. I'm sorry. Okay? So we want to find what is the greatest common factor between these three terms. What do y'all think here? What can we take out of each of them? Can I take out an x? Does each one have an x? Yep, we can take out an x. Ooh, I can also take out a y. Can I take out a y squared? Ooh, because that only has a y. So we can only take out, we can take out an x, and we can take out a y. Can we take out anything else? No. So then we think to ourselves, well guys, what is x cubed y divided by xy? Well, that's going to be x squared. And the y cancels out. Okay? And then we go here, x squared y squared divided by xy is just going to be xy. And xy cubed, well, the x's are going to cancel. Y cubed divided by y is going to be y squared. Now, guys, do these share anything in common with one another? No. So are we done? Yeah. So, y'all, my greatest common factor in this case is x, y. Now, guys, this method of doing this is called upside down division. And I like upside down division just because it actually will save us a little bit of space. But I'm going to show you what it looks like if you don't do upside down division, okay? You don't have to. I just like it. I think it looks cool. All right? So I'm going to show you what it looks like without upside down division. All right? So if we do 8a4b cubed, see? We want to find the greatest common factor between these three terms. Okay? We got 8a4b cubed c, 4a cubed b cubed c, and last but not least, 12a squared b cubed. Okay? So guys, on these three, what is my greatest common factor, y'all? What is the greatest common factor? Let's start with our number. Well, 2, but also, can we go bigger than that? Yeah, we can go with 4. So guys, my GCF would be 4, and then, what with my A's here? What is the largest A that I can take out? Ooh, we have an A squared, don't we? But, oh yeah, we can't do A cubed because we only have an A squared. Ooh, but we can at least take out A squared of everything, right? So you can take out the lowest, you look for the lowest exponent, right? Okay, what about B? B cubed, B cubed, B cubed. Yes, we can take out a B cubed of all of them. And last, can I take out a C? Why not? The last one doesn't have a C. So guys, what you can do is you can sit here if you want to, because you want to check. So I'm going to take out 4a squared b cubed, 4a squared b cubed, 4a squared b cubed. When I do the upside down division, this is what we are doing. So instead of having to write it 3 times, it's just nice to write it that one time on the outside. Does that make sense, y'all? So then we go here and we do 8 divided by 4 is 2. A4 over A squared is A squared, and then C. Then we look here, 4 over 4, 1. A cubed over A squared is just A. My B cubed cancels, and we're left with C. And then we have 3. 3. Because A squared cancels and B cubed cancels. Do y'all feel good about that? So then we look at these 3 and we say, is there anything else we can take out of this? No. So we know we were correct with our GCF of 4a squared b cubed. You always want to check it to make sure that there's nothing in common with the ones that you have remaining. All right? So it doesn't matter to me either way that you write it. I personally like to do the upside down division, but I just want you to show you what I'm doing in my head when we do upside down division. Okay? So if I ask you for the GCF, like on your homework, there will be times where I just say, what's the GCF? You just give me the greatest common factor. Okay? Now there will also be some times where I'm going to ask you to actually factor the polynomial. Okay? So we want to factor each, oh, sorry, I'll move it down. Factor each polynomial by removing the GCF. Okay, guys, we're going to factor each of the following polynomials by removing our GCF here, okay? So, how this is going to look, y'all, is I'm going to go here, and, oh, there's not a, oh, man, that's supposed to be a 4, because I skipped number, sorry about that. That's not a 5, that's a 4. Okay, so we go right here with number 4, not 5. Okay, so number 4, let's see here. I'm going to factor, we want to factor out the GCF and rewrite it in its factored form. So guys, 4x squared minus 3x. What is going to be my greatest common factor of this problem right here? Well, what are we going to get? What is our greatest common factor here? What do they have in common? Is there any integer that we can take out between 4 and 3? No. Okay, what about variables here? What can we take out any common variables? Yeah, we can take out an x. Can we take out an x squared? No, because that one doesn't have an x squared, right? This just has an x. So we can take it out an x. So now, 4x squared divided by x is going to give us 4x. Are y'all comfortable with that? Negative 3x divided by x gives us negative 3. So y'all, now we have our GCF right here, and we have what we've divided out here. So my factored form, if I was going to factor this polynomial, my answer would be x times 4x minus 3. So guys, this is important. This right here is the simplified form. Okay? This guy right here is your factored form. All right, y'all? Shh. So, Will, I'd love you to turn around, sir. So check this out, y'all. On here, are you just trying to test me? Thank you. So, guys, last unit, we started with the factored form, and we distributed it into the simplified form. Now, guys, we're starting with the simplified form, and we're finding the factored form. It's like we're unmultiplying, right? We're dividing. And, guys, the reason we're doing this is because sometimes it's better to have it in simplified form, and sometimes it is much better to have it in factored form. So we need to know how to go back and forth between the two. So guys, a great way to check and see if you have the right answer is you can kind of remultiply here. X times 4x is 4x squared. X times negative 3 is negative 3x. Ding, ding, ding. They're the same, so we did it correctly. Do y'all feel good about that? So guys, we are literally removing the GCF and finding our factored form. Okay? So we're kind of undoing what we did the entire last unit. I'm teaching y'all how to go in reverse here. Okay? So now, let's do another example. We want to factor out the GCF and give me my factored form here. So we are going to have of 10y cubed plus 20y squared minus 5y. So, y'all, we need to think to ourselves, what is the greatest common factor here? What is our GCF? What do we have that we can take out of all of them? We have a y. I like to start with my numbers first. We do have a y, so I'll put that guy here. Can we do a y squared? Nope, just y. What integer can we take out of all of them? 5, yes. So we can take out a 5. So we can take out a 5y. Are y'all cool with that? So now, 10y cubed divided by 5y is 2y squared. 20y squared divided by 5y is 4y. And negative 5y divided by 5y, well, negative 5 divided by 5 is negative 1. Y divided by y cancels. So, hooray! So, we have our GCF, which is 5y, and we have what we have remaining after we've divided it out, and we have 2y squared plus 4y minus 1. So, this guy right here is going to be our factored form, right? And so, these are both your factored forms when you have it with the parentheses. So guys, when we talk about factored form, it usually has a parentheses. And you can check yourself two ways. You can check yourself just like we did on the last one. 5y times 2y squared is 10y cubed. 5y times 4y is 20y squared. And 5y times negative 1 is negative 5y. Check. Guys, you want to check yourself. Now, I personally think it's actually easier just to multiply it back really quick. But if you want to find how can we check our equivalency on our calculator, I want to show you all some cool little tips here. You can put your simplified form, the form they give you. I'm going to switch to x, and y1, so that's 10x cubed plus 20x squared minus 5x. And then I'm going to put my factored form in the y2 here. So I'm going to say 5x parentheses 2x squared plus 4x minus 1. Y'all good with that? So I put 1 in y1 and 1 in y2. We check our table. Oh, wow. I was way up here on the 8s. And guys, what you can see is you check your table for equivalency. If your y values match exactly, then they are equivalent. So these two are equivalent with one another. Do y'all feel good about this so far? Okay, factored form versus simplified form. Okay, so now we're going to switch. We're going to do a couple more examples here. Okay, so let's take a look at number 6. All right, I got to get down here. All right, so I want you guys to find the factored form of negative 8x squared plus 12x. Okay, and then I'll also write number 7. Why not? We're going to do 49xy squared minus 28x squared y. Okay. So for this first one here, guys, this one's a little different because your leading coefficient is negative. So guys, I'm going to give you a little hint right now. Whenever your leading coefficient is negative, you want to factor out the negative, okay? So we will factor out a negative. So in this case, what is the greatest common factor between 8 and 12, y'all? 4. So we're going to factor out a negative 4 because we lead with a negative 8. What else can we factor out? Yeah, so it's negative 4x. So then we sit here and we say, cool, negative 4x divided by negative 8x squared, or negative 8x squared divided by negative 4x gives us positive 2x. And then 12x divided by negative 4x is going to give me negative 3. So my factored form, in this case, would be negative 4x times 2x minus 3. Y'all feeling okay about this so far? If we wanted to check ourselves, we would multiply it out here. That would get me negative 8x squared plus 12x. Yep, it works. Okay? And so an important thing to note here is if the leading coefficient is negative, you must factor out a negative. Okay? So if your leading coefficient is negative, you must factor out a negative. Whoops. Y'all feel good about that? Super, super important there, okay? If your leading coefficient is negative. Okay, so on number 7, what is my greatest common factor that we can pull out between these two? What do we got here, Will? Was that a hand raise? It can be. What is the greatest common factor between 49 and 28? 7, right? It's kind of nice. Number 7 has the greatest common factor of 7. Okay, what about my x's and my y's here? We got x and x squared, so we can pull out at least one x. And a y squared and a y, so we can pull out a y. So we got 7xy. Y'all feel good about that? So now 49xy squared divided by 7xy is just going to be 7y. That's all that we're left with. And then negative 28 divided by 7 is negative 4. X squared y is just going to be x. Right? Yeah. Awesome. So we are left with 7xy times 7y minus 4x. So this is our factored form. You want to check it real quick. 7xy times 7y is 49xy squared. 7 times negative 4x, that's negative 28, x squared y. Yep, we're good. All right, guys, so you want to check yourselves. You can always go back and check yourselves with this. So we are taking out our factors and putting it in this factored form with the parentheses, okay? So we are not putting it in simplified form. We are putting it in factored form. All right. So, guys, does everyone feel pretty good about just taking out the GCF there? All right. So now, guys, we are going to talk about what it looks like to factor out a binomial. Okay? So we are going to factor each expression by removing the common binomial factor. All right? So the way that I'm going to show you the following 3 problems, you will never be given a problem in this method. This is kind of the middle step that you will have to learn how to create. But I want to show you guys what it looks like so that you feel comfortable doing that. Okay? So for number 8 here, I'm going to rewrite this guy. Kind of give yourself a little bit of room on the side. So I'm going to rewrite this as 7 parentheses x minus 3 minus 2x parentheses x minus 3. So I will probably never give you a problem in this way, but it is good to see what we need to remove here. All right? So what do these two guys have in common? What is common between them? Just the x minus 3. Because, guys, the factors of this first term are 7 and x minus 3. The factors of my second term are 2x and x minus 3. So, technically, the factor that they have in common is x minus 3. Does that make sense, y'all? So, if I divide 7 times x minus 3 over x minus 3, that guy's going to cancel. And all we're going to be left with is 7. If I do negative 2x times x minus 3, and I take out an x minus 3, what are we going to just be left with? Negative 2x. So now, my two factors are this guy, x minus 3, times 7 minus 2x. Do y'all feel okay with that? We took out a common binomial factor. So the common binomial factor in this case was x minus 3. All right, so let's take a look at number 9 here. Okay, so I'm going to give myself plenty of space. I'm going to say x times x squared plus 4 minus x squared plus 4. Okay, So what do these two guys, these two sets, have in common? X squared plus 4. So we're going to take out an x squared plus 4. I'm going to put it in my lovely little parentheses out here. And guys, when I divide x times x squared minus 4, what are we left with? We're just left with x. Oh, okay. If I take out my x squared minus 4 here, what am I left with? -1. Aha, it's like a -1. Very, very good. So often, people will put 0 right there. Remember, it's like a negative, it's like a little invisible -1 there. So our final answer of our term here would be x, oh man, I should have done it in pink, sorry y'all, x squared plus 4 times x minus 1. All right? Y'all feel okay with this so far? Any questions about how we're pulling out that common binomial? All right, last example for us on this page here. We are going to have, let's see here, 3x squared times x plus 2 plus 4 times x minus 7. All right, guys, what do they have in common with one another? Well, we're looking at the whole factor. What do they have in common with one another? Nothing. So y'all, on here, for this particular one, this one cannot be factored. All right, y'all? Take attendance. There we go. All right, so this particular one cannot be factored. That's super important. I wanted to show you guys one because the parentheses do not match. So guys, that does happen. A lot of the ones I will give you will be nice and factorable. But in the real world, not all of them are able to be factored. Gentlemen, okay? Y'all feel okay with that? Not all of them are able to be factored. Okay? So now we're going to jump to what it looks like to factor by grouping. So the whole reason I showed you this method is so that factoring by grouping will be possible for you, okay? So now I'm going to show you what it looks like to factor each polynomial by grouping. All right. So next page, we are going to factor each little guy here by grouping. So how this is going to work is we're just going to do two little examples here, and hopefully we feel pretty good about this. So I'm just going to do number 11. So I'm going to write this out, and we have 12a cubed minus 9a squared plus 20a minus 15. All right. So, y'all, is there anything from these four terms that all of them have in common? Can we take out something from all four of them? No, not 3 is the closest it comes, but then 20 kind of screws that up. So, guys, there's nothing. So what we are going to do is we are going to group these into two separate little things. Okay? So we're going to group this as 12a cubed minus 9a squared. We're going to factor something out of this guy. And then I'm going to separate my 20a minus 15, and we're going to factor something out of this guy. So we have two separate things we will be factoring. All right, y'all? So I'm going to write it like that. Okay? So now that we have two factors, now can we factor anything out of just these first two? 12a cubed minus 9a squared. 3 is our number, because they're both divisible, and then a squared. Excellent job. So 12a cubed divided by 3a squared is going to give us 4a. And then negative 9a squared divided by 3a squared is going to give us negative 3. So if we were going to rewrite this guy, it would look like 3a squared. If we factored this one, times 4a minus 3. Y'all feel good about that? Okay, now let's factor the second one here. And this is where the magic happens, okay? So what is our common factor between 20a and negative 15? 5? Are y'all good with 5? Okay, now check this out, guys. What's 20a divided by 5? 4a. What's negative 15 divided by 5? Look what we did, y'all. Check this out. Our GCF, we have plus 5 times 4a minus 3. Guys, we just made this factorable because we have that same binomial here. Okay? So now, technically, what can I take out of this right here? 4a minus 3, right? That's going to cancel this guy and this guy. And what are we going to be left with? 3a squared plus 5. So if we factor out the 4a minus 3, now we have our two binomials. We have 4a minus 3 times 3a squared plus 5. And that is our final factored form. Do y'all feel good about that? So we've created this lovely polynomial out here that we can factor by grouping. Okay? Now guys, I do recommend checking this. Okay? So I would recommend checking this. We do 4a times 3a squared. That's going to give us 12a cubed. Looking good so far. 4a times 5, which gives us 20a. All right. We're a little out of order, but that's okay. Negative 3 times positive 3a squared is negative 9a squared. Once again, we're a little out of order, but we should be all right. And negative 3 times 5 is negative 15. So do the problem they give us, and then when we multiply it out, do they match? Yeah. Our middle terms are switched, but that's okay. All right, y'all? Do y'all feel good about this? So this right here is our factored form. That is our simplified form. Just so that we feel extra good about this, that's our simplified form. And this is our factored form. Okay? We have our simplified form and our factored form. All right, let's do the very last problem that we have today, number 12. Okay? And then I want y'all to, and then we'll have plenty of time to get started on our homework. We will do 15x cubed minus 10x squared minus 6x plus 4. Oops, y'all can't see that. Sorry about that. So can y'all see any of this? Yeah, there's nothing we can take out. So we are going to have to group this one again. So we are going to group this into two separate groups here. So I'm going to say 15x cubed minus 10x squared. Then I'm going to kind of like separate it over here into negative 6x plus 4. Y'all good with that? So this being said, all right, Miss Amari, what can we take out of this first group here? What is our greatest common factor? Between 10 and 15, we got 5. That's exactly right. And then can we take out any variables? Yeah, but we can also take out, can we take out an x squared? Because see how that one has x cubed and that has x squared, so we can actually take out an x squared, right? Because if we just took out an x, there'd be something left over. Does that make sense, Amari? Cool, cool. So we got a 5x squared there. So now we're going to say 15x cubed divided by 5x squared is going to give us 3x. Negative 10x squared divided by 5 is going to give us negative 2. So if we wrote this guy, it would be 5x squared times 3x minus 2. Y'all feel good about that? All right. Let's take a look here. What can we take out of negative 6x and 4 here? Well, what does 6 and 4 have in common? 2. And it's a negative, so we got to take out a negative 2. Okay? So negative 6x divided by negative 2 is going to give me a positive 3x. 4 divided by negative 2 gives me a negative 2. So did it work, y'all? Did we find our little magic number here? Yeah, we got a 3x minus 2. So this becomes minus 2 times 3x minus 2. All right, guys? Now I'm going to be super honest with y'all. When I get to this spot right here, I don't usually do my upside down division again. I usually go ahead and just write out 5x squared minus 2 as my first one, and then I write out 3x minus 2 as my second one. Does that make sense, y'all? I go here and I know that I've reached it, okay? But if we want to go ahead and do it properly here, if we take out our 3x minus 2, cancel that out, cancel it out, we are left with 5x squared minus 2. Does that make sense, y'all? So if you want to go ahead and do that, you're more than welcome to. But as this gets easier, hopefully we don't have to, all right? You do want to go ahead and check yourself, though. 5x squared times 3x gives us 15x cubed. 5x squared times negative 2 gives us that negative 10x squared. Negative 2 times 3 gives us negative 6x. Negative 2 times negative 2 gives us that positive 4. And we look here and we see that they're the same. All right? So do y'all have any questions for me on how to factor by grouping? No? Awesome. Okay. Well, we're going to go ahead and get started on our homework right now.